The first topic today I am going to start the applications of derivatives. The weightage of this chapter will be 5 marks. In that, there are 4 subtopics I told already. One is errors and approximation. It is a very easy topic where if you can remember the 4 small corner lines, then you can get to the question and answer. In the important points you have to find to get to this errors and approximation is 1. Let y is a variable, then derivative of y, dy is error or change in y, and dy by y is called relative error in y. Dy by y into 100 is percentage error in y. Follows? For example, if r is the radius of a circle, the error in it or change in it is dr. Dr is error in radius. If A is area of the circle, dA is error in area. If the B is the volume of the sphere or any closed circuit, then the dB is error in it. Now it is coming to an important note. Most of the students are confused to control the answers. The very important is what is the relation between the degrees and radians. 180 degrees equal to pi radians, we know it. But in application derivatives questions, sometimes we are getting 1 degree. If the total problem is in degrees or in radians, no problem. If some part is radians, some part is degrees, you have to change everything into the one common unit. So that's why this is you have to remember. 1 degree equal to 0.0174 radians and 1 radian equal to 57 degrees approximately. Second, for sphere, R is radius, B is the volume, S is the surface area. V equal to volume of the sphere is 4 by 3 pi r cube. Differentiate on both sides with respect to dV by dr equal to 3 and 3 cancel 4 pi r square. dV equal to 4 pi r square dr. What is 4 pi r square? This is nothing but the circumference will be coming, that is what surface area will be coming for that sphere. So now I am going to start the applications and previous lecture questions in this. Follow this. The first problem of this application, in find the approximate value of root 82 they are asking. If the question comes 81, it is a nursery rhyme like that, you can tell root 81 is 9. For 81, we know that the square root of it is, the square root is 9. We know it. To find the square root of 82, let given be first what design it is having. So it is in the design of y equal to root x model, where you can take the known figure x is 81 and here extra 1 dx is 1. Such that x plus dx equal to 81 plus 1, 82. Now the differentiate the equation 1 on both sides with respect to x, we are getting dy by dx equal to 1 by x. Root x derivative is 1 by 2 root x. So dy equal 1 by 2 root x dx, that is 2. Now the answer is very simple. Root 82 equal to original value y and dy. Y plus dy is coming. Y is root x and 1 by 2 root x dx is equal to dy. Now substitute x for 81 and dx for 1. Simplify, we get 9 plus 1 by 18. 9 as it is, 1 by 18 is 0.035. The approximate answer will be root 82 will be coming as 9.0555. That is the first problem. Same way, you think about the second question. Find the approximate value of cube root 65 they are asking. For 64, we know that cube root of 64 is 4. For 64, the cube root is 4. No. Because of that 65 error, to find the cube root of 65, this is first. What mathematical design is contained? Let given be in the form of y equal to cube root x. So y equal to cube root x is nothing but x over 1 by 2, that is 1. Where you can typically select known value for x. X is 64, dx equal to 1. Such as x plus dx equal to 65. Now differentiate the given equation or forming equation 1 with respect to x that gives dy equal 1 by 3 x to the power of n minus 1. Simplify dy equal 1 by 3 x power minus 2 by 3 dx. That is equation 2. Now, cube root of this simplify is nothing but y plus dy and 1 and 2 right hand side and substitute wherever x 64, wherever dx you can give 1, that comes as 4 plus 1 by 48. 1 by 48 is nothing but 0.0283 after different. So 4 plus add these two, the answer for the second question is 4.0283 is coming. Similarly, suppose the question comes, sir, how to find out a log 3? They are also the same picture. Function you can select that one y equal to log x. Differentiate 1 by x, add those two. Like that subject to. Now the third question is application of trigonometrical non-standard values. Please. Yes, my third question will be first two are square root and cube root. Now the third question is application of sine non-standard values. Approximate value of how to find out the sine 62 or whatever it is. In this question, sine 62. If it is by geometry 60, everyone can give the answer with 3 by 2. So for x equal to 60, then we can give sin x and sin 60 are root 3 by 2 value. Now to find sin 62 value, consider x is a known value 60 and the error in it is 2 degrees. Let given is in the form of previous two cases. First question what I am explaining, y equal to root x model. Second question is y equal to cube root x model. Now the third is y equal to sin x model. So y equal to sin x means differentiate on both sides with respect to x. That comes dy by dx equal to cos x, dy equal to cos x dx. So y and dy in your hand, then same game. Sin 62 degrees equal to y plus dy. Sin x plus cos x dx. Sin x is sin 60, that is coming root 3 by 2. Cos 60 into 2 degrees here, it is very important. Cos 60 is 1 by 2 into 2 degrees. 2 degrees by 2 is coming as 1 degree. Already I have given first part as the important notification relation between degrees and radians. 1 degree equal to 0.0174 radians. So that root 3 1.732 by 2. Simplification that comes approximate value of sin 62 is 0.8840. Adding these two. Next, the fourth question. It is an applied problem on geometrical approach. If the radius of a sphere is increasing from 7 cm to 7.02, for example, a balloon is there, normal radius is 2, while gas pumping in it, the volume of the balloon is increasing like that. So the radius of a sphere ball is increasing from 7 cm to 7.2 cm. Then find the approximate increase in its volume of the sphere. So the question related to sphere, for sphere R be the radius, B be the volume. R is, if it is 7 directly, we can know it. Because it is increased from 7 to 7.02 means error is 0.02. So R is 7 centimeters. dr is 0.02. So let volume of sphere is V 4 by 3 pi r cube. That comes, then differentiate on both sides with respect to that comes dy by dr is 4 by 3 pi r. It is r cube derivative is 3 r square. 3 cancel 4 pi r square. So our requirement is dv, approximate value. So dv equal to 4 pi r square dr. By simplification, that comes 4 into 22 by 7 into 7 square into 0.02. That gives the answer 12.32. But you see the options, all 4 options are very, very close. One option is given 12.23, another is 12.32, another is 13.12, another is 12.13. So means 12.32, that is the second option. These are the 4 questions completed the first spell as square root, cube root, sine problem, and one applied problem on geometry. Now the question number 5, I am going to plot now. The radius of a circle is measured 6 centimeters with another 0.02 centimeters in it. then what percentage error in the area is calculating. Because given design is related to circuit, R is the radius, dr is the error radius, AB is the area, A equal to pi r square, differentiate on both sides with respect to dA equal 2 pi r dr is coming. So substitute our percentage error is nothing but what? dA by A into 100 is 2 pi r dr by pi r square into 100. Simplify that one, pi cancel, one denominator, numerator is cancelled, we are going to get 2 dr by r into 100. Simplified answer is 1 by 14, option C is coming. On the same base, find the nearest approximate value of 2023. It is the square root and model number 1. Next, and the 8th question also find the approximate value of cos 61. The model number 3, sin 62 I am explaining. And the same way you can approach cos 61. And one more geometrical approach is semi-vertical angle of a cone. Semi-vertical angle of a right circular cone is 30 degrees is given. If the height of the cone is 6.125, then approximate value of the volume of it related to the volume of the cone, you can write dV by dr. Okay, with this errors and approximation application for EAPCET level, these are the very common base levels will be expected. And the next video I am going to start the main measure of the application derivatives. Thank you, one and all.